So if I was to find the x-intercept for this equation, I would set the first root, x plus 3, equal to 0, and then I would set the second root, x minus 2, equal to 0. Now, in order to solve for x, I'm going to subtract 3 from both sides, so x is by itself. Then I'll have x equals negative 3. In order to solve for x for the second x-intercept, I will add 2 to both sides. X will equal 2. If I was to graph, x is 2 means I go right 1, 2, put a point, because the x-intercept's 2, 0. Then for x is negative 3, I go left 3, because the point's negative 3, 0. My graph is quadratic and would look like that. Okay. Now, what we're going to learn today is how many x-intercepts we'll see compared to how many roots or answers there actually are. Okay. For instance, in this equation, we have two groups. Okay, we have two factors. Because we have two factors, first factor, second factor, there's going to be two x-intercepts, okay? There's also going to be two roots, okay? Roots are the value of the x-intercept, okay? While the x-intercepts are the ones you see on the graph. Now, where this is kind of tricky is whenever we have an equation like y equals x plus 5 squared. Okay? Here we have one group, but it's squared. So to find the x-intercept, I would set x plus 5 equal to 0. Subtract 5 from both sides. And I would get x equals negative 5. Okay? So on a graph, I would go left 5, and that would be my only x-intercept. The problem is there's two roots, okay? There's two roots for this answer. X plus 5 squared can be written as x plus 5 times x plus 5. So there are two roots, but because both roots equal 5, there's only one x-intercept. This is called a double root, okay? This is called a double root. It's called a double root because the same root repeats itself, okay? Now, double roots and quadruple roots bounce on the x-axis, okay? Here's the x-axis. Our double root was at negative 5, so our graph bounced, okay? Meanwhile, single roots, okay, single roots cross through normally, all right? Now, let's look at another example. Y equals 2x minus 3 to the third power, okay? Again, there's one group, so there's going to be one x-intercept, all right? But the exponent is 3. That means that there's going to be 3 roots, all right? So if I set 2x minus 3 equal to 0, I'm going to add 3 to both sides. 2x will equal 3. I then have to divide by 2, and x equals 3/2, or 1.5, okay? So, I'll go over 1.5, and this is called a triple root. Anytime you see a triple root, it'll be an S-curve, okay? Anytime you see a triple root, it'll be an S-curve. But, again, there's only one x-intercept here, alright? Now, sometimes you'll have awkward equations, alright, that look like this. It'll be y equals x plus 1 squared times x minus 3. Well, this is a double root. So it's going to bounce. While this is a single root. The single root will just cross through the axis. So let's solve real quick. X plus 1 set equal to 0. Subtract 1 from both sides. X will equal -1. X minus 3 set equals 0. Add 3 to both sides. X will equal +3. Okay, now because this is a positive function, the ending behavior goes up. But now, whenever I get to the x-intercept of -1, because it's a double root, my graph is going to bounce. Okay, so if I come up, when I hit it, it'll bounce back down. Okay, and again, double and triple roots have one x-intercept, but 2 or 3 roots.